right, hi you guys. So this is our Unit 2 review number 1. So this is the first review of this first part of the Unit 2 test. And here we go. Let's go for it. So it says the graph of a function f of x is shown in the coordinate plane. And so here's f of x. We've got a parabola here. And it says which statements describe the graph of f inverse of x? So in the graph right here, this is f of x. This is not the inverse, but they want us to use this to help us figure out which statements are true about f inverse. So what we should do is remember, we can Freaky Friday some points. We're given a graph, just like the poster activity that we did at the beginning of this unit. So let's find some exact points here. There's one, that's the vertex of the parabola. Got these two. Let's see, there's another one. Looks like it's about right here, which means there's one symmetric on the other side. And then looks like we got -2, 6, and 4, 6. So if we Freaky Friday those points, we're going to plot them. Okay, so let's just start from left to right. So this is -2, 6. If you Freaky Friday the coordinate -2, 6, you're going to get 6, -2. If we Freaky Friday -1, +1, we're going to get 1, -1. So switch them. Switch the x and the y. The Freaky Friday of 0, -2 is -2, 0. The Freaky Friday of 1, -3 is -3, 1. Remember, that's the vertex of the upward-facing parabola, so this point should be the vertex of the sideways parabola. And then Freaky Friday of 2, -2 is -2, 2. Freaky Friday of 3, 1 is 1, 1, 2, 3. The Freaky Friday of 4, 6 is 6, 4. And so we have our sideways parabola here. And that is f inverse of x. Okay? So we've got f of x and we've got f inverse of x. Okay? All right. So here we go. Which statements describe the graph? So this is a select all that apply. Anytime you get a select all that apply question, that means more than one answer option is going to be correct. All right, so here we go. It says the graph of f inverse and the graph of f of x are symmetric about the line y equals x. Yeah, these are inverses. Because these are inverses of each other, all inverses reflect across y equals x. So y equals x is the diagonal line that goes through the origin. If I were to draw that in, right? And it basically divides it in half. It's like they're looking in a mirror. They're looking at each other in a mirror on that diagonal. So yes, that is true. So we can select that first one. The graph of f inverse has a maximum at 1, -3. Well, 1, -3, that is the vertex of the upward facing parabola. That's f of x, not f inverse. And it's a minimum, not a maximum anyway. So that's out. The graph of f inverse contains the point 6, 4. So let's look at the red graph. That's f inverse. 6, 4 is right there. Yeah, it does contain that point. The graph of f inverse shows a function. Well, f inverse, if I were to hold my pen over it, does not pass the vertical line test. So as itself, it is not a function. We can restrict the domain, but it does not show a function. The graph of f inverse is symmetric about the line x equals 1. No, inverses are not going to be symmetric about the line x equals 1. Plus, if you look at it, x equals 1 is this vertical line. Imagine I drew a vertical line through 1 right here. There's nothing that the graph is symmetric about that line. The graph of f inverse has an x-intercept at -2. Is the red graph crossing through the x at -2? Yup, it sure is. That is true. So there were 3 statements that were true here. Was the first, the third, and the last. So I like it when you guys highlight your answers. Makes it a little bit easier for me to grade instead of going searching for your answers. So you always want your teacher happy with you when she's grading your stuff. Just saying. This next one is supposed to be number 2, not number 4. So that's my bad. I need to fix that. So it says a square root function is shown in the coordinate plane. So there's our square root function right there in the graph. What are the domain and the range of this function? All right, it all boils down to this critical point. And the coordinates of that critical point are -3, 2. So remember, when we're talking about domain, we're talking about the x's that are being used. So it helps if we just go ahead and write what the domain is. So the x value that's being used here is a -3. Does it ever use anything smaller than -3? No, it's going from -3 to positive infinity. Or you could say x is greater than or equal to -3. Okay. So, oh, that's not a -3, that's a -5. My bad, -5. Oh my gosh, Mrs. Garcia. You're probably screaming at the computer, Miss Garcia, that's wrong, it's -5, not -3. Between 4 and 6 is 5, right? So, there we go. So x greater than or equal to -5, so we know it's not this one, not this one, not this one. It's got to be this one. It's got to be D, but let's take a look at the y, the range. Well, the y value being used there is a 2, but notice that the graph never goes above 2. It only goes 2 and below. So that means we're going from -infinity to 2, or as an inequality, that would be y less than or equal to 2, to positive 2. I was about to write -2, but that's positive 2. All right, and that's exactly what it says right there. So D is the correct answer. So for domain and range, it always boils down to that critical point that it's at. It's either a vertex or the point that it starts at. All right, next page. Oh, I guess I didn't print front to back. It's okay. All right, this isn't number 5. This is number 3. We need to fix that. All right, so it says, what is the solution to the equation? So we need to solve. This is just like CFA number 3. All right, so let's go for it. We need to isolate the radical. That's step number 1. So we need to get rid of that -3. So we're going to need to do the opposite, +3, so we can move it to the other side. So we're going to get the square root of x minus 4 is equal to 5. Okay, now the radical is isolated. So now we could take the radical off. You undo a square root by squaring it, but whatever we do to one side of the equation, we have to do the other. Poof, the x minus 4 gets to come out. 5 squared, 5 times 5 is 25. And then we need to add 4 to both sides. So x is equal to 29. But remember, one of the steps you had to do in that CFA is you need to check it. Okay? When you check it, you always plug it back into the original. So we're going to replace the x in the original equation with a 29 and see if it works. So square root of 29 minus 4 minus 3 on the outside of that radical. Is it going to equal 2? And we need to test this out. Okay, well, 29 minus 4, that's a 25. Oh, this pen is out of ink. Sorry. That's 25. The square root of 25 minus 3 is what we have left, but the square root of 25 is 5. 5 minus 3, yep, that does equal 2. So this checks out. So x really does equal 29, and C is the correct answer. All right, so there's that one. Number 4, because remember my numbering was off. Mario solved the equation x equals square root of 16x plus 1 plus 10 using the steps shown below. He said that the solutions are x equals 3 and x equals 33. What was Mario's first mistake? He made a mistake. What was the mistake? Okay, well, let's go through his work and see what he did. So, did he write down the problem correctly? Because sometimes that's the problem. Nope, he did that correct. And then it looks like he moved that 10 over, which means he had to have subtracted it. That's the only way to move it properly. And yeah, I see x minus 10, so there's the -10 that he subtracted. And then the only way to undo a square root is to square both sides. So he squared both sides. And then x minus 10 squared became this. Well, when we have a quantity squared, that means we have that same quantity times itself twice because it's squared. X times x is x squared. X times -10 is a -10x. -10 times x is another -10x. -10x minus 10x is -20x. And -10 times -10 is positive 100. Okay, so far so good. And then the stuff inside the radical got to come out. All right, anytime you get an x squared, we need to move everything over to the other side and equal 0 on the other. So let's see, that means you needed to subtract 16x from both sides and subtract that 1 from both sides. That way we can get 0 on that right-hand side of the equation. Well, 100 minus 1 is 99. Negative 20x minus 16x, they're both negative, so we add them and keep the negative, is negative 36x. So far so good. He's doing really good. All right, and then it comes to factoring, so we can do product sum. Let's see, the product is 99. The sum is negative 36. Two numbers that multiply to to positive 99 and add up to negative 36. Well, let's test out as negative 3 times negative 33. Negative times negative is positive, and 3 times 33 is 99, and negative 3 minus 33, yeah, that's going to equal negative 36. So he did good. X minus 3, x minus 33. And then when you solve it, you're going to get x equals 3 and x equals 33. When you add the 3, add the 33 to both sides, you're going to get positive values. All right, so these are the solutions he got, but it says that he made a mistake, and so far there aren't any mistakes. What did he forget to do, guys? He didn't check it. He didn't check for extraneous solutions. So when we check it, that means we plug it back in to the original equation. So I'm going to start with the 3. Plug in a 3 for all the x's. So 3, is that going to equal the square root of 16 times 3 plus 1 plus 10? Pull out my monster calculator here. 16 times 3 is 48. 48 plus 1 is 49. And so we're going to get 3. Is that going to equal the square root of 49 plus 10? Oh, not 47. Square root of 49. Well, square root of 49 is 7, which is why I was thinking 7. But 7 plus 10 is 17. 3 does not equal 17. So x equals 3 is not a solution. It is extraneous. It's a solution that we got legitimately, but it doesn't work. All right, so the 33 is probably going to work, but we still need to check it. So replace all the x's in the original equation with a 33. And let's test this out. So let's see, 16 times 33 this time. Well, that's 528 plus 1 is 529. Is that a perfect square? Yeah, it is. It's 23. So 33, is that going to equal 23 plus 10? Yeah, 23 plus 10 is 33. It checks out. So x equals 33 is the only solution. So it wasn't both of them. It was just x equals 33. So let's see, part A. He did not find the square root of the terms under the radical. No, he did that. He evaluated x minus 10 squared incorrectly. No, he did that correctly. He factored x squared minus 36x plus 99 incorrectly. No, he factored everything properly. He did not check whether the solutions are extraneous. So D is the answer. All right, that was number 4. Number 5, because this is not number 7. Number 5, it says, which graph is the inverse of f of x equals the square root of x plus 3? All right, we're looking for the inverse of this, okay? So there's a couple different ways we could go. We can Freaky Friday it and figure out its equation and graph it, or we can realize this is a square root function, and it has been shifted to the left 3 units. So from the left of the origin, because all parent functions start at the origin, that means since it's a square root and it's a positive square root, this is the top half of the sideways parabola. So it's going to look like that. But I need to find which graph is the inverse of this, the inverse of this. So this is not what I'm looking for. I'm looking for the inverse of that. Okay, so what I need to Freaky Friday that. Well, the Freaky Friday of negative 3, 0 is 0, negative 3. And remember, that's going to be an upward facing parabola, but it's only going to be the positive side of it because I only have the positive side of the sideways parabola. Okay, so that means that, oh, there it is. It is C. So that's one way to do it. The other way, the graphing part, because you don't know your graphs very well, you can always fall back on Freaky Friday. Change f of x to a y. Freaky Friday, switch the x and the y. And then solve for y. So to get a radical off, we're going to need to square both sides. So x squared is equal to poof, y plus 3. And then we have to subtract 3 from both sides. So y is going to equal x squared minus 3. So the parent parabola function shifted down 3 units, which is that right there. That's the half of a parabola shifted down 3 units. Only half of it's going to show because only half of this one shows. It doesn't have the plus or minus, so we're not going to see the top side and the bottom side of the sideways parabola. All right, and that is, let us see. That was number 5. This isn't number 8, this is number 6. Which of the following functions is 1 to 1? So remember, to be 1 to 1, it has to pass both the vertical and the horizontal line test. Well, these are all either a cubic or a cube root function. And as long as it's a transformation of the parent cubic or cube root function, then all of those are 1 to 1. It's the ones that have extra junk in the trunk that are not it. So if we can't see a shift of the parent function, then we know that it's not 1 to 1. Like this one, we can see that it is a cubic and it has been shifted. Plus 1 on the end means up 1. So that is a shift of the parent function. That one is 1 to 1. It says to select all that apply, so that one's 1 to 1. Okay. Well, the next one is a cube root function. Can we tell which way it was shifted? Yeah. That minus 2 underneath the radical means it was shifted to the right 2. That is a shift of the parent function, so it is 1 to 1. X cubed minus x. Now that one, because it's got an x and not just a number, and it doesn't have parentheses like this one does and a number added, I don't know, that's not in standard form. That extra x is going to make an extra hump. So this has got extra junk. It's not going to pass the horizontal line test. It'll pass the vertical, but it's not going to pass the horizontal. So to show you, I don't have Desmos, but I've got this here. So I can graph it. So that would be x cubed minus x. And let me make sure that my window is good. That should be good. See here? Because it's got more of a dip, when I do a horizontal line test, it's going to go through 1, 2, 3 places at once. So it's not going to pass. Now, you're not going to be able to graph anything in a graphing calculator. So you have to know, hey, that extra x is extra junk. It's going to make it not pass the horizontal line test. So it ain't it. Same with this one. There's extra x's underneath that radical. It's not just an x with a number added or subtracted to it. So this one also has extra junk in the trunk. It's not going to pass both the vertical and the horizontal line test. And I'm not going to show that to you in Desmos because you don't really need to know that. You just have to recognize when it's extra junk. This one, however, though, we can see that it is shifted to the right 2 and up 3. It is a cubic, which means it is a transformation of the parent cubic function, and so it is 1 to 1. And then the last one, it's a cube root, and we could tell it's got some shiftings of the parent function. That means it's going to the left 1 and down 2. So because it's a shifting of the parent cube root function, it is 1 to 1. It's going to pass both tests. And there it is. So 4 options, the first 2 and the last 2. These are all 1 to 1. And now we have selected all that apply. All right, this one is number 7. It says, what is the inverse of f of x equals x minus 2 cubed plus 7? So we need 2 Freaky Friday. So y equals x minus 2 cubed plus 7. Step 1 is to change the f of x to a y. Step 2, Freaky Friday. So switch the x and the y. So x is equal to y minus 2 cubed plus 7. And then we need to solve for the y. So we need to start isolating this. We need to move that plus 7, which means we have to do the opposite, which is subtract. So x minus 7 equals y minus 2 quantity cubed. And then we have to undo the cube, and we do that by taking a cube root on both sides. So poof, the y minus 2 gets to come out because it was a cube, and we cube rooted it. On the other side, it's just the cube root of x minus 7. We have one more thing to do to solve for y, and we need to get rid of that minus 2, so we're going to need to add 2 to both sides. I cannot add these numbers. One's an inside number, one's an outside number. Do not add them. So we're going to get y equals the cubed root of x minus 7, and then plus 2 is just tacked on at the end. But we have to write this in function notation. So it should be f inverse of x is equal to the cubed root of x minus 7 plus 2. Now, these should say f inverse of x, but that's okay. We see it right there, letter C. Letter C is it. Gotta highlight my answer. Also, guys, take note. See all this work that I'm showing for these types of questions? If you get an answer, if you just circle an answer and you happen to get it correct, you're not going to get points. You have to make sure to show your work. No work means no credit. And I believe that one was the last one. All right, that's it, you guys. Have a good one.